Good morning, boys and girls. Meteorologist Steve Caparotta here, back with Cap's Corner Summer Camp. Already on to episode number 6. Now, last week we talked all about hurricanes. This week we're going to talk more about hurricanes, but specifically how to track them on a map like this one. A paper hurricane tracking map. I'm going to show you where you can download these as well. But this is how I grew up tracking hurricanes. Probably how most of your moms and dads and your grandparents did too. It's pretty cool to do, I think, and it also teaches you along the way. So I'm going to show you how we do this. So let's go ahead and get into the lesson. Now today I'm actually going to be sitting at my computer. I wanted to do this lesson this way this week. I think it makes it a little bit easier for me to point out some of the features that I wanted to show you guys as we walk through this lesson. So let's first start off with sort of a map of the globe, of the earth. And if we're going to track hurricanes on a paper map, we've got to understand latitude and longitude. So first off, let's talk about latitude. What is latitude? Well, latitude, we're talking about lines that run east and west around the globe, okay? They're sometimes also called parallels, but probably better for you boys and girls to just think of them as lines of latitude today. Now, we have one really important line of latitude that's known as the equator. The equator basically divides the earth in two. North of the equator, so up here, and I've got a compass down at the bottom left to show us our directions, but north of the equator, we call that the northern hemisphere, and then south of the equator, we call it the southern hemisphere. So where the equator is, we say that is 0 degrees latitude. Then, as we look at these lines of latitude, we can break them up kind of how we want to. I've broken them up by 10-degree increments. So on this map here, we go from the equator being at 0 degrees latitude to 10 degrees north, 20 degrees north, 30 degrees north. And by the way, 30 degrees north passes through South Louisiana, and so on. And these actually go all the way up to 90 degrees north. That would be the North Pole. And then as you go south of the equator, same story, except they are 10 degrees south, 20 degrees south, and so on. 90 degrees south would be the South Pole. So these lines of latitude tell us how far north or south a given point is from the equator. So again, remember the equator, that's an important line to remember, and that's kind of a good reference point. Now, the other key lines that we use, these are lines of longitude. So remember, our lines of latitude run east and west. Our lines of longitude run north and south, as I've shown here on the map. So there's one really important line of longitude. Just like we have one really important line of latitude, we have one really important line of longitude. That's known as the prime meridian. This connects the North and South Pole, passes through Africa and parts of Great Britain and a place known as Greenwich. But this is 0 degrees longitude. The prime meridian is where longitude is 0 degrees, okay? So remember, latitude divides the Earth or the planet into two, north and south. Longitude and the prime meridian divides the Earth into east and west, okay? So now as we look at our lines here, if we go west of the prime meridian, then we start counting 10 degrees west, 20 degrees west, 30 degrees west, and we go all the way to 180 degrees, okay? Now, where we are in Louisiana, one of the main lines of longitude that passes through 90 degrees west. And I'll show you more on that later on in the presentation. But as you go west of the prime meridian, that's how we label these lines of longitude. And then as you go east of the prime meridian, 10 degrees east, 20 degrees east, 30 degrees east, and we have 180 degrees off to the east. Okay? So our two important lines that we use are the equator, that's 0 degrees latitude, and the prime meridian, 0 degrees longitude. Where those two intersect. Now, what's really great about latitude and longitude is we can get a set of what we call coordinates. If we take a value for the latitude and a value for the longitude, we can figure out exactly where we're looking on a map. So if we talk about the coordinates where the equator and the prime meridian intersect right about in here, that's 0 degrees north and 0 degrees west, okay, where those two lines intersect. So let me explain more on that. Where we track all of our hurricanes in our part of the world, in the Atlantic Ocean and the Gulf of Mexico, all of those are north of the equator and west of the prime meridian, okay? So when we plot tropical systems and hurricanes, the coordinates that we always use are going to be some latitude north, some longitude west. So we're going to have a number here, some degrees north of the equator, and we're going to have a number here, some degrees west of the prime meridian. Still confused? Don't worry about it. I'm going to walk you through this with some specific examples. All right, so this is kind of back to our paper hurricane tracking map, which you guys can print out on our website. I'll show you where at the end of the presentation. I've got 3 different versions that I've made and shared. But this one is kind of focused in on our part of the world and the Gulf of Mexico. So as we look at this map, let me point out a couple of things before we get started. So when I was showing you the big map of the globe, I broke it down in 10-degree increments. You remember that? So for the latitude, I went from 0 degrees being the equator, then I plotted 10 degrees north, 20 degrees north, 30 degrees north. Well, this map has a little more detail, so we have more lines to it. So let me point out some important lines. Can you see here? 20 degrees. This is 20 degrees north as we follow that line across. And then each one of these lines is 1 degree of latitude. So the next one would be 21. 22, 23, 24, then we hit 25. Okay, so I've labeled them every 5 degrees, but we've got a line for every single degree. I know it's probably getting a little confusing, but hopefully the examples start to make more sense. And then as we look at our lines of longitude, remember those go north and south. We're kind of up and down on our map, right? These I've also broken down into 5-degree and 1-degree increments. So I've got the labels every 5 degrees. So here is 90 degrees longitude, which passes through southeast Louisiana, right through New Orleans, in fact. Here is 95 degrees west. Here's 100 degrees west. But we've also got the lines in between. So if this main one is 90 degrees west, the next one is 91, 92, 93, 94, 95, and so on. Okay, so hopefully it makes a little bit of sense. So for our example today, we're going to use Hurricane Laura, which hit Louisiana in 2020 last year. It was a very powerful hurricane, did a lot of damage, especially in southwest Louisiana. So I'm going to give you a few different sets of coordinates for Laura, and I'm going to show you exactly how to figure out where on the map that is and how to plot it on the paper map. So here we are. We're going to start out when Laura was in the Caribbean. So we're given this set of coordinates. If you watch me on the news or any of the meteorologists, Jay, Jeff, Jared, will give you these coordinates as we track the storm. So at this point in time, August 24th last year, we got this set of coordinates. 21.2 degrees north, 80.6 degrees west. So how do we plot that on a map? So let's start out. Remember, this first number, that's our latitude. The second one's going to be our longitude. So how do we plot it? We're going to start out with our latitude. So to figure out where that is on the map, let's figure out where 21 is. So I've highlighted it. If this is 20 coming across, then we know the next one north, the next one up is going to be 21. So we have 21.2. So 21.2 is going to fall somewhere between 21 and 22 degrees north. So the red line, I've highlighted 21 degrees latitude. So next, I'm going to highlight 22 degrees latitude. So we know now our point is somewhere in between these two red lines, somewhere between 21 and 22. Let's come back to that in a second. Now, let's focus in on our longitude, 80.6. So I'm going to highlight for you where exactly 80 longitude is and 81. So here's 80. There's our longitude 80. Here's longitude 81. And look what happens now. Now I've got a red square right in here where all those lines kind of intersect. So now we know that our coordinates are going to be somewhere within this box. And I'm going to highlight it for you, okay? So that's the area we need to focus in on as we plot the storm here, just south of Cuba. So 21.2, again, this is 21, so 21.2 is going to be just a little bit above 21, because to get from 21 to 22 on our map, it goes 21.1, 21.2, 21.3, 21.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then it's on to 22. So 21.2 is just a little bit above 21. 80.6 is going to be between 80 and 81. So if we remember, again, it goes 80.1, 80.2, 80.3, 80.4, 80.5 would be right in the middle. So 80.6 is going to be just a little bit past the middle. So here's where we end up with our point. 21.2 is a little bit above 21, and 80.6 is a little bit beyond about the halfway mark between 80 and 81. Does that make sense? I know it's a lot to absorb and kind of confusing, but guess what? The more you boys and girls practice this, the easier it will become and the more it will make sense. So let's try it again. That's the first point. Here's our second one. 23.7 north latitude, 87.0 west longitude. Now what's going to help here is we have an even number. We're right on 87.0. That's going to put us right on one of our lines of longitude. So that might help you with this point. So let's start out with our latitude though. So 23.7. So here's where 23 and 24 north latitude are. These two red lines. Remember, here's 20. So we go up 21, 22, 23. Here's 24. So our latitude's going to be somewhere in between these two red lines. And now let's find 87 degrees longitude. Here's 85, right? And here's 90. So we know it's got to be somewhere in here. So if we go 85, 86, 87 should be right in there, right? So let me highlight it for you. So there is 87. So now we focus in on this little red square to figure out. So we know with 87 degrees longitude, our point's going to be on that red line, that vertical red line somewhere. Now we just got to figure out how high up it's going to go. So 23.7. 0.7 means it's a little more than halfway between 23 and 24. So as I now plot it out for you, here's where we end up with our point. It's a little bit above halfway. So it's on 87 longitude and a little more than halfway up between 23 and 24. All right, let's do two more of these. So hopefully it starts making a little more sense with time. This is even a better example because we get really lucky here. Both our latitude and our longitude this time fall right on lines. So hopefully this will be maybe the best example and easiest to understand. So 27 degrees north latitude, 92 degrees west longitude. So let's find our 27 north latitude. So we've got 25 labeled here. That one's easy to find, right? So we go up 25 to 26 to 27, right in there, right? So there's 27 degrees north latitude. Now we've got to find 92 degrees west longitude. So here's 90, 91, 92, right? And I'll highlight that one for you. So here we go. So in this case, we're lucky. We only had to draw two lines, and they intersect right there. And you know what that means? That means our coordinates, our point, are right where those two lines intersect. So that one's a little easier. So there's our third point. I'm going to plot one more now after Hurricane Laura made its way inland into Louisiana. So the last one we're going to plot, 31.9 degrees north latitude, 93.1 degrees west longitude. So let's find 31.9 north. So here's 30. 31 is going to be this next one coming across just north of Baton Rouge. All right, so highlight that for you. And now we'll highlight 32. Here's 32. So we know it's going to be somewhere between these two lines. And now let's figure out our longitude. So we want to find 93. So here's 90, 91, 92, 93. And then we can follow it up. So I'll highlight 93 for you. And we're going to highlight 94 because 93.1 falls between 93 and 94. So now we know our point is somewhere in this little square right here. And let's highlight that square for you. So 31.9, that means it's almost to 32, right? So it should be closer to this line. 93.1 is really close to 93, right? So let's see where that ends up falling as I plot it for you. So here it is. Here's your last point. So 31.9 is almost up to 32, but 93.1 is just barely past 93. All right? Does that make a little bit of sense? I know it's kind of confusing and a lot to absorb, but once we plot out all these points, and really you can plot a lot more, you'll get a lot more coordinates along the way if you track a storm with us. But if you plot them out, you can draw a line along the points as you go along, and eventually you would end up with this. Here's the path, the track that Hurricane Laura took as it came into Louisiana, and that's how you can track it on a paper hurricane tracking map. So if you want to print out some of these paper tracking maps like the one I just showed you and the one I used, go to our website, wafb.com/hurricane. Once you go to that page, there you see it, where it says hurricane tracking charts. You might have to get mom and dad to help you out. But right where it says that, if you click right there, it'll give you a link where mom and dad, or you can print out some of those hurricane tracking maps and then give this a try yourself at home. Also, if you go to my Caps Corner page, wafb.com/Caps Corner, I'm going to have posted a few different sets of coordinates for you boys and girls to practice with. So I'll post Hurricane Laura for you. I'll post Hurricane Zeta. That was another one from last year. And I'm also going to post Elsa, which is the one we dealt with just recently, last week, okay? Didn't hit Louisiana, but that was the storm we were tracking last week. So that'll give you a chance to practice with some storms that have already happened. And once you practice that, hopefully you'll be able to do it kind of real time the next time we have a storm out there. So, again, boys and girls, I know it's kind of confusing and that's a lot to absorb, but if you start practicing with the maps like this one, it'll become easier with time. Trust me, I did it when I was really young, and it just took a little bit of practice. You start picking it up pretty quickly, and it's pretty cool once you give it a try. All right, so we're through week 6 now. So 2 more lessons left after this one. Next week, we're going to be talking all about tornadoes, and then we're going to wrap it up talking about how meteorologists like myself, how we actually make our forecasts. So with that, that's all I had today. If you've got any questions about tracking hurricanes or about hurricanes in general that you get to ask last week, pop those in the comments on YouTube or on Facebook, and I'll be happy to take them.
All right, welcome back, everyone. Hopefully you learned a little bit about how we track hurricanes, especially for the boys and girls that maybe haven't done it the old school way, like I grew up doing it, moms and dads and grandparents, like we talked about in the video. So if you've got any questions, this is maybe a session that might not have a lot of questions, but if you've got any questions, now is the time. I'm going to be peeking over here to my side to kind of take a look at any questions that may be coming in. There was one comment from Bridget saying, hopefully this is aimed at children. We should have all learned this in elementary school. Yes, this is Caps Corner Summer Camp is mostly aimed at children, but it's for kids of all ages, anybody that wants to learn about weather. But indeed, yeah, most of us should have learned about this growing up and in school. Those of us that are a little bit older, but for the younger kids, want to teach you how we track hurricanes. I think it's kind of cool to do as storms are out there, instead of just pulling up an app or getting on your computer, seeing how it actually works. Kind of gives you, I think, a better idea of how the storm is actually moving through time as well. So I'm going to take a peek over again just to see if we have any, Valerie here said it'd be fun to get my hands on a paper tracking chart. So with that, Valerie, you heard me mention, and in fact, I've got a few printed out here. So I made last summer, and Josh Boyd and our team helped me out with these, but I've got 3 different versions. One that's focused on the Gulf of Mexico. We've got one that kind of covers the Gulf of Mexico and the Caribbean, and then one that's even wider, pretty much covers the entire Atlantic and Gulf of Mexico. So depending on where the storm kind of starts out and just how much detail you want to be able to see, you can use any of those. So let me show you where those maps are located. Give me just a second here, and I'm going to pull it up. So if you go to our website and you go to wafb.com/hurricane, you see it up here now. So right in that red bar, you've got the disclosures, you've got the weather app, you've got our Facebook page, and then there you go, hurricane tracking charts. And once you click on this, it'll give you a link, a printable link, PDF, of all 3 of those tracking charts. So there you see the one that's focused on the Gulf of Mexico. There's the one with the Gulf, the Caribbean, and parts of the Western Atlantic. And there's the one that covers the entire Atlantic basin. So really easy to print those out if you want. I know a lot of you remember the days when we used to have the tracking charts that for as long as my time was here. I guess those were always at McDonald's where you could pick it up. We stopped doing that a number of years ago. We just weren't getting sort of the demand for people to have those paper charts, even though I love them. So instead of doing that, though, we've now got these on our website that you can get anytime you want. You don't have to go anywhere to get them. You can be right, assuming you got a printer at the house, you can print them out whenever you've got time and check them out. One other thing I need to mention, we did have a little technical difficulty launching the segment on Facebook, those of you watching on Facebook. So apologies for that. Facebook always changing how things work. So it was a few minutes late, but if you missed the beginning and want to watch it, a couple different ways you can go back and see it. Number one, go to wafb.com/Caps Corner. So let me take you to that page here. So as is with the case, all of our lessons are posted here, all the ones I've done so far this summer. What you'll do is you'll scroll down, and this one should be posted here probably in just a little while. In fact, looks like our team is on it. They've already got it up. So there you go. So if you missed it on Facebook or missed the beginning, you can watch it here. You can also watch on YouTube or in our WAFB Plus app. I'll try to go ahead and post a link on Facebook too. I know some of you are just kind of Facebook centric, so I want to have it available for you. But also note, I mentioned at the end, so coordinates. So for the kids that want to go ahead and practice, I've got 3 sets of coordinates up for Hurricane Zeta from last year, Hurricane Laura, and then Hurricane Elsa from this year. If you click on any of these, you'll get a printable list of coordinates. And then down at the end, I did print a map that shows you what yours should look like or something similar at the end if you practice. So obviously you can cheat if you want to, but the idea is take a blank map and try to plot the storm on your own, then compare it with the one at the end and see how you've done with that. So with that, let me take another peek over before we wrap it up and see if we have any questions. Yeah, Abby saying hopefully very young children. Look, yeah, no doubt this is aimed at children, but you guys would be surprised when it comes to anything with geography and maps. Sometimes we kind of trail behind a little bit of that. So I bet you'd be surprised that kids are maybe older than you would think that can learn from stuff like this as well. I go into schools all the time, and it's quite a range on what you'll see given from neighborhood to neighborhood, school to school, on what kids know and what they don't know. So I think there's many that can benefit from this stuff. Harriet mentioned she still has one packed up. Yeah, many of us still have those. All right, so I mentioned at the end, we'll probably go ahead and wrap up. Let me take a peek over. I forgot to look. No questions coming in on YouTube, so hopefully we answered everything you guys wanted. So only 2 lessons left, 2 more Mondays now. So next week, I'll talk all about tornadoes. So that'll be next Monday at 10 o'clock, same place, same time. Try to have the Facebook issue resolved this time, launch on time on Facebook. And then the final week in July, I'll kind of explain how meteorologists make forecasts. Yeah, I get that question a lot when I go out and do those school talks. How do we actually make a forecast? And it's not, sometimes people think, so I go on air, first we start at 4:30 in the morning. So some people think, okay, you show up a few minutes before and you go on air and that's that. No, there's a lot of homework on my end that goes into a preparation. So we'll kind of talk about that and explain how all that works. Let me take one more peek before we wrap it up just to make sure I'm not missing anything. So Sharon, Pat, Pearl, all saying good morning. They're watching. Thank you guys for watching. Harold, appreciate everybody that's on here watching this morning. And I'm just taking one more look. All right, not seeing any more questions. So with that, we'll go ahead and wrap it up. Again, appreciate everybody watching this morning. And give me just a second here. We will see you again coming up next Monday at 10 o'clock. See you then.